Baik, Bapak, Ibu, dan rekan sekalian, acara jam sudah menunjukkan pukul 2:05. Kita akan mulai acaranya. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, Bapak, Ibu, dan rekan sekalian. Terima kasih atas kehadirannya dalam webinar hari ini. Kita akan membahas bagaimana solusi Akcp bisa membantu banyak perusahaan dan data center di Indonesia guna mendukung climate change. Jika ada pertanyaan, dapat disampaikan dalam kolom chat dan nanti akan kita bahas dalam sesi Q&A. Untuk pertanyaan terbaik akan mendapatkan voucher OPPO senilai Rp100.000 untuk 6 orang terpilih. Webinar ini didukung oleh Aptiknas, Asosiasi Pengusaha Teknologi Informasi dan Komunikasi, Event Cerdas, Mitra Transformasi Digital Anda, dan media partner biskom.web.id, portal IT and Law Indonesia. Kami dari PT Daya Cipta Mandiri Solusi selaku partner dari Akcp, dan dalam kesempatan kali ini kita akan membahas bagaimana implementasi solusi Akcp bisa membantu banyak perusahaan dan data center di Indonesia. Saya berikan kesempatan pertama kepada Bapak Fanky selaku CEO PT Daya Cipta Mandiri Solusi untuk menyapa kita semua. Silahkan, Pak.
Baik, terima kasih Mbak Nurma. Selamat siang Bapak Ibu rekan-rekan semua. Terima kasih untuk kesempatannya bisa bersama dengan kita pada siang kali ini. Dan kesempatan kali ini memang agak unik ya, agak menarik karena kita mengangkat tema yang mungkin agak jarang diperhatikan orang ya, bagaimana kita bisa berikut ya, mengambil bagian, mengambil andil dalam mengurangi ya dampak dari perubahan iklim ya atau climate change ya. Dan sejujurnya salah satu produk yang mungkin kita khususnya perusahaan kami telah gunakan dan implementasi di customer, salah satunya adalah Akcp ya. Dan hadir bersama kita sangat menarik pada siang kali ini hadir Presiden CEO dari Akcp, Nicholas Barrowclough, dan juga Pak Yono Wijaya selaku data center expert yang selama ini banyak membantu dan implementasi terkait juga dengan Akcp. Kita akan dengarkan sharingnya, nanti kita akan ikuti bersama, mudah-mudahan apa yang nanti kita akan dengar bersama, ini membantu kita, terutama khususnya dalam pengelolaan data center, dan juga bagaimana kita bisa mengambil bagian ya dalam mengurangi dampak dari perubahan iklim ya terkait dengan produk-produk IT yang kita gunakan. Baik, saya kembalikan dulu ke Mbak Nurma, silakan.
Terima kasih Pak Fanky. Saya akan menginfokan untuk narasumber kita dalam webinar hari ini yaitu Mr. Nicholas Barrowclough at Akcp Presiden at Akcp. Good afternoon, sir. Dan selanjutnya Bapak Yono Wijaya dari Data Center Expert.
Hai, good afternoon.
Ya, selamat siang.
Siang, Pak. Kegiatan ini akan dimoderatori oleh Pak Fanky selaku CEO PT Daya Cipta Mandiri Solusi dan Ketua Aptiknas DKI Jakarta. Silakan Pak Fanky.
Oke, baik. Terima kasih Nurma. Jadi Bapak Ibu rekan-rekan, seperti yang tadi saya sudah sampaikan di awal bahwa memang kita akan membahas tentang bagaimana produk Akcp bisa mereduce atau ikut andil ya dalam mengurangi dampak dari perubahan iklim atau climate change ya. Mungkin Bapak Ibu rekan-rekan perhatikan dalam berita-berita mungkin 2-3 minggu yang lalu katanya Jakarta ini akan tenggelam ya karena adanya perubahan iklim secara global yang mengakibatkan karena kenaikan suhu ya, jadi air laut meninggi juga gitu ya. 2030 katanya Jakarta akan tenggelam. Wah, ini tentu akan membuat kita semua pemain khususnya di lingkup IT ini harus melihat ulang ya apa yang sebenarnya kita bisa lakukan terkait dengan ini. Nah, saya jadi ingat langsung salah satu solusi yang kita bawa untuk data center. Ya, saya dan Pak Yono ini sudah interaksi lama terkait dengan produk Akcp dan kami banyak implementasi di banyak tempat di data center khususnya di Indonesia. Ya, jadi dan kesempatan siang kali ini juga hadir Nicholas dari Akcp-nya langsung yang akan men-sharingkan bagaimana produk Akcp dan bagaimana produk Akcp juga bisa digunakan untuk mereduce climate change ya. Nah, Nicholas akan present dalam bahasa Inggris ya. Nicholas will present in English, but you can ask later Nicholas in bahasa, so I will translate to English ya. So I think Nicholas, are you ready?
Yes, I'm ready.
Okay. Yeah, if possible, you can also turn on the video so everybody can see your face.
Currently I'm kind of in the middle of a construction site, but yeah, I'll video on.
Okay.
My house is under construction, so I'm sitting on
on
the floor trying to find somewhere that's not too noisy.
Okay, no problem, Nicholas. So, Bapak Ibu rekan-rekan silakan ya
I
nanti.
apologize also for the background noise. You might hear some drilling.
Ya, oke. Nah, jadi Bapak Ibu rekan-rekan nanti kita akan dengarkan dulu presentasi dari Nicholas. Setelah itu nanti Pak Yono akan share juga implementasi dari Akcp. Kemudian kita akan masuk ke sesi Q&A ya. Okay, I think we can see the presentation from Nicholas first. Okay, Nicholas, the screen is yours.
Okay, I share my screen. All right. Hi, good afternoon, everyone. So I'm Nick Barrowclough, President of Akcp, and today I'm here to speak to you about reducing climate change through the data centers. So I'll just give you a little background, first of all, on Akcp and who we are. So we're established in the USA in 1981 and have over 30 years experience in professional sensor solutions. And we created the market for the network temperature and environmental monitoring power solutions for the data center. Today, we have over 150 employees in several countries and over 200,000 installations worldwide. And we're the largest manufacturer of the networked wired and wireless sensors. We're also the only company to have brought a dedicated LoRa-based wireless solution to the data center with our wireless tunnel technology, which builds on LoRaWAN with our own protocol layer on top. And these improvements include such things as immediate broadcast on thresholds and acknowledgement of received data, which doesn't exist in the standard LoRaWAN protocols. So some of our customers worldwide, we have a large customer base, which includes governments, banks, militaries, Fortune 500 companies, providing monitoring solutions that have been deployed in everything from data centers, telecoms, warehouses, cold storage, mining operations. So today, we're here to talk about data centers and climate change. So the demand for data centers is growing with increased popularity of cloud-based computing, video streaming services, social media, and a lot of this has been compounded, of course, by the COVID-19 driven IT requirements with, most of the world switching to a lot of work from home, virtual conferences have increased, such as the one we're doing today. Homeschooling, online classes and so on have all put increased demand on technology and data centers around the world. So this has led to an increase in not only edge data centers, but also an increased rollout of hyperscale data centers as well. And by 2022, it's estimated that around 4.8 zettabytes of data is going to be processed through data centers worldwide, which is a huge amount of data, and all of that data requires obviously servers to process it. So, talking about data centers and energy consumption, in 2017, US data centers alone counted for 90 billion kilowatt hours of consumption, which, to put that into perspective, that's the equivalent of the output of 34 500 megawatt power plants. And that's just in one country. That's, obviously the US houses a lot of these hyperscale data centers, but there's other countries around the world which are consuming similar amounts of energy. Combined worldwide, you could probably times that number by 10. So this results in a huge amount of energy use, but also a huge carbon footprint. And in a time when climate change is becoming a more prominent issue, data centers are becoming under increased scrutiny for their role that they have to play in climate change. The question is, though, can our modern world live without them? Which, of course, the answer is no. So the question then becomes, is how are we going to meet these challenges going forward? How do we make data centers more sustainable? How do we lower their carbon footprint? And balance that at the same time against increased demand. So it's not a case of just lowering the carbon footprint of the existing ones. It's how do we lower that carbon footprint and meet increasing demand? So it's kind of a two-folded problem. So in addition to power that data centers use, they also consume large quantities of water as well. So most of the cooling systems used in data centers, they use water as their medium for cooling, unlike kind of home air conditioning systems that are using compressed expansion of gas. A lot of them are using water. And if you factor in as well the water which is used to generate the power that those data centers are using, then it results in serious implications for the water supply. And this is in a time where overpopulation is leading to also increased pressure on water resources, and climate change is also increasing pressure on water resources. So again, you've got kind of multiple issues here. It's not only the amount of water that data centers are consuming, there's also less water anyway with climate change. And in addition to that, we've got increasing populations, which are also putting pressure onto water. Increased population results in increased need for agriculture, which is also a huge consumption of water. So some of these data centers are in a situation whereby they need to increase capacity, but they cannot increase their cooling capacity because they simply cannot get the water. Some local governments are saying, the data center has got as much water as we can provide it. If we start giving you more water, there will not be enough for the city and the farms. So again, this is another major issue that data centers are going to be facing and face increasingly in the future. So that's a background to some of the issues that data centers are facing and the impact that they are having on climate change and the impact that climate change is having on the data centers. So in summary, the challenge is basically to overcome, and how we will meet these challenges going forwards is what the rest of the presentation will be about. So in order to meet the future needs and the world's hunger for technology, but also remain sustainable, there are challenges that must be overcome, and improving the cooling efficiency, lowering the energy consumption of the servers, and reducing water usage could be highlighted as the three main aspects. And as you will see, a lot of these are interconnected. If you can improve cooling efficiency, you can reduce water consumption. If you can lower the energy consumption of the servers, you lower the cooling requirements, which also then lowers the amount of water required, not only to power them through the generation of electricity, but the water used to cool them. So if you can improve one of these, it will improve all of them. And the one in the middle is the one to target. If you can lower the energy consumption of the servers, then you will automatically be able to improve the cooling efficiencies and reduce the water usage. So how do we go about doing that? Well, there are different strategies that we can employ. So strategies for improving cooling efficiency would include changing to something such as submerged cooling technology. So some of you may have heard of this. It's basically the concept whereby the actual server itself is submerged in a bath of dielectric fluid. And that dielectric fluid circulates in a closed loop system through a heat exchanger. And it's possible to run a huge amount of server capacity through the submerged cooling systems. So a typical rack that maybe would max out at around 6 to 10 kilowatts when using traditional cooling methods, you could be running a 30 kilowatt rack, which is unheard of with cooling using traditional methods that you find in a data center these days. If you were to switch to something such as submerged cooling systems. So basically the way server submersion works is, air is a poor conductor of heat. In fact, air is an insulator, which is why when you see mountaineers going up Mount Everest, they're wearing big, thick, puffy jackets, which are filled with feathers. Those feathers trap the air and it keeps them warm because air is actually an insulator. So it's very poor at conducting heat. So when you pass air through the IT cabinet, when you're passing air through the servers, you're passing this cold air through and it's picking up the heat from the servers and transferring it out, but it's not doing it as efficiently as water would. Water is a much better conductor of electricity, not just electricity, but also heat, which is why if you jump into cold water, you will feel cold a lot quicker than if you walk into a cold room, because the water is able to conduct that heat from your body a lot faster. So the same thing happens. If you pass this cold water through the servers, it will actually carry away more heat. But obviously water and electricity doesn't mix. So how do you do this? Well, you use something called dielectric fluids. So these are engineered fluids that are non-conductive, and you can submerge the servers inside of this fluid. And basically the servers will boil the liquid. And as the liquid boils, it evaporates and carries that heat energy away with it to a condenser where it condenses back to a fluid and is pumped back then to the servers. So it goes through a closed loop system, and this is called a two-phase liquid submersion cooling, because you're going through two phases of the fluid. You're going from a liquid to a gas. You also have single stage as well, immersion cooling, which is basically very similar to what you would find with a traditional air system where the air is passed through the servers, but in this time it's the liquid is passing through. So not only are you able to more efficiently carry away the heat energy from the servers, but you are also as well able to allow the servers to operate at a higher temperature, which means they can run at a higher clock speed. Now, this idea of liquid cooling is not something particularly new. Gamers have been overclocking CPUs using liquid cooling for many years. So you're able to take a PC that is rated with a clock speed of 6 gigahertz and run it at 10 gigahertz, because you're able to do that by the liquid cooling. You can remove sufficient heat, you can overclock the CPU. So this would then tie into, as I said, there are challenges to overcome, and all of these are interconnected, a lower consumption of energy by the servers. So if you can increase the clock speed and increase the capacity and processing power that server can do for the same amount of energy consumption, then you are improving its efficiency. Yeah. If you could take a car that runs at 100 kilometers an hour and run it at 200 kilometers an hour by burning the same amount of fuel, then you will increase the efficiency of that engine. And what we're effectively looking at doing here is the same thing. You're going to put the same amount of energy into that server, but you're going to be able to get more work out of it because it's sufficiently cooled. So that's one of the technologies you could look at, is submersion cooling. It's not without its challenges. It requires a dramatic shift in the data center, the layout, and so on. But there are companies out there now that are providing kind of vertical submersion cooling racks. Traditionally, you would have seen them probably look more like a bathtub, and the servers are lined up in them. Another thing is as well is you can fit a lot more servers into a smaller space. So not only is it more efficient in actually cooling the servers, but the servers take up less space. So you can get a much higher density for a given amount of space. So, a rack that previously, a 42U rack that was running at 6 kilowatts, you could now run that same 42U space but be able to run it at 30 kilowatts. Because you're also taking out as well a lot of other aspects. So if you're using the liquid cooling, the servers no longer need fans. So you are removing the consumption of energy. You know, the servers consume energy when they spool up their fans because you no longer need those. And it also reduces the amount of space that's being taken up. Another challenge, though, with liquid cooling is solid state hard drives need to be used because the traditional magnetic spinning disks won't work in immersion cooling systems. So this is a technology that's coming through, but it's going to require a lot of effort and change of mindset by the data centers to really adopt it. And it's something that possibly we're not going to see really taken on board on a large scale for possibly another 10 years because of the kind of cycles that the data centers go through before they're ready to start actually taking out old equipment and putting new in. But that's one way that you can, you know, a surefire way of improving the efficiency of the cooling system. So another that we're probably all aware of, and I don't need to go into too much detail, is containment. You know, this is already something that many data centers have done, which is basically just containing your hot and cold aisles and making sure that the hot and cold air doesn't mix. And we'll touch upon more of that later because that's kind of one of the more common things that you're going to come across these days. And we'll discuss how some of the challenges with containment can be met. And also as well, I want to address some of the misconceptions that some people have about containment as well. So the next point here is the lower energy consumption of the servers. So through new semiconductor technologies, transitions to solid state hard drives rather than magnetic disks, it's possible for servers to consume less energy for the same or increased compute power than what they previously had. So as the energy consumption of the server equates to lowering of the cooling requirement, modern servers are able to operate at higher temperatures, meaning the set point of the cooling systems can be increased, which obviously then means that you are consuming less energy in cooling and less water in cooling. So you begin to see how all of these are interconnected with each other. You know, by lowering the energy consumption, you automatically lower the amount of cooling requirement, which reduces the amount of water being used. All of which ultimately has a positive impact on the environment and also has a positive impact on the bottom line of the data centers as well. So the final point there is the reduction of water usage. So by lowering the energy requirements of the servers, you lower the amount of water used in cooling, but also the amount of water used in the generation of the power. And you know, even some renewable sources of energy require water. Yeah. So obviously wind power doesn't. Hydroelectric power requires water, but it's kind of reusable water because in a, say, pump storage hydroelectric power station, the water is cycled around. But if you consider something such as geothermal energy, which is used extensively for power generation in Iceland, for example, that actually consumes water because you're having to add water to the geothermal energy to make the steam. Now, obviously, in a coal-fired, gas-fired, or nuclear power plant, they are consuming huge amounts of water in the generation of that power for cooling the core of the nuclear reactors and for generating the steam to spin the generators. So when you consider the data center water consumption, you must factor in the amount of water used for the generation of the power that data center is using, as well as the water which is being used to cool the data center as well. So going on to the next slide here, we have some data center metrics. So you've probably heard of PUE. It's a bit of a buzzword in the data center industry. So that's power usage effectiveness. And that is how efficiently your data center is utilizing its power versus its cooling. You also have water usage effectiveness, which is a ratio of the amount of water used per year versus the amount of kilowatts consumed by the IT equipment. We also then have two values here, which are delta T and delta P. So delta T is a temperature difference and delta P is a pressure difference. And I'm going to go into more detail on each of these in the following slides. So power usage effectiveness is a calculation, the formula of which you can see on this slide here, which is the total facility power divided by the IT equipment power. It's a ratio of the amount of power consumed to run the servers versus the power consumed to cool the servers. So if we consider a PUE of 2.0 is an average PUE, it means that for every $1 you spend on IT, you spend $1 for cooling. A PUE of 1.0 would be a situation where you have 100% free cooling from outside air. That would mean for every $1 spent on your IT loads, you're spending $0 for cooling. Obviously, that is an idealistic situation if you could get 100% free cooling. Not applicable to somewhere like Indonesia, where obviously it's hot outside, you're not going to be bringing in cold air from outside. But that is why you are seeing large hyperscale data centers, the likes of Facebook, Amazon, Google, have been opening up data centers in Alaska, Iceland, and Norway, because they have cold weather for at least, half of the year. And so you can get a large amount of free cooling by bringing that outside air into the data center. Even when you're bringing that outside air in, though, the cooling may be free, but there is still an associated cost. You've got fans to drag that air in. You've got fans to circulate that air around the data center. And in places like Alaska and Norway in the winter, when it's cold, it is also very dry. So you have to humidify that air. One of the issues with very dry air inside of a data center is that you can get arcing of electricity. So conversely to not wanting a very high humidity where you're going to get condensation, you also don't want a very dry environment for the servers to be working in, because you've got possibilities there of static electricity and arcing of electric through the dry air. So even in those very cold countries, you are never going to get 100% free cooling. However, it has been possible to achieve PUEs of about 1.1 by some of the very well-run hyperscale data centers being run by the likes of Google and Facebook. They have been able to get those very low PUE numbers. However, for most of us who don't have the budgets and are constrained by the just natural environment of where you are, for example, in Indonesia, you're never going to achieve that kind of level of PUE, but you could aim for a PUE of somewhere around 1.3 to 1.5 if you have proper management and containment of. So although PUE numbers talk mostly about kind of the financial cost, obviously there is an associated environmental cost. If you lower the amount of money you're spending on energy, you are also lowering the amount of energy you're using, which means you have a lower carbon footprint and a smaller impact on the environment. So it's beneficial in two ways to data center administrators. Everyone cares about the environment, but a lot of businesses care more about their bottom line. And, they may say, well, it's very nice, I'm going to be lowering my carbon footprint, but it's going to result in me having to increase my cost to my customers, and I'm going to lose customers, and I can't do that. So there is two benefits to this. Not only do they lower their overhead, but they are also helping the environment in the process. So we'll move on now to water usage effectiveness. You can see here I have a diagram which shows the kind of water cycle of a data center. And you can see there the water which is being used for the generation of the power, and also the water that is being used for the cooling of the data center. So there is another data center metric called water usage effectiveness, or WUE, which was started by the Green Grid several years ago. So this is a ratio of the annual water consumption versus the annual IT load. So it takes into consideration water used on site for cooling, air humidification, and on-site power generation. So the lower the WE number, the less water that is used per kilowatt of IT load. So for example, WUE of 2 means for every 1 kilowatt hour of electricity that you're using for your IT load, you are consuming 1 liter of water to cool it. So there's another calculation, which is a more accurate and complete, known as WE source. So this also takes into consideration the amount of water used to generate the electricity off-site as well. So by looking at this metric, you will be able to identify how efficiently your data center is using the water. The next metric that we've got that is important for us to consider is the delta T. So although not directly related to energy consumption and water consumption, it is a byproduct of those. Now, most people, when they consider the delta T of a data center, they are thinking about the delta T across a rack. That is the temperature difference between the air entering the rack and exiting the rack. But there are, in fact, 4 key delta T's in the data center that you should consider. There is the crack to rack. So that is, what is the temperature difference between the air exiting your crack and the air entering the rack? You then have the delta T that everyone thinks of, which is the rack front to rear. You then have the rack rear to the crack inlet. And you also have the delta T across the crack. That's from the inlet to the outlet. So monitoring the delta T allows you to check the temperature for the servers are correct, but also that the cooling energy is not being wasted and it's being used efficiently. I'm going to go into more detail now about that. So the first one of these delta T's is the crack to rack. So the closer these values are, the better. If the air coming out the rack is 20 degrees and the air entering the rack is 22 degrees, it means you have a delta T of +2. So it means that the air has warmed up and you have lost efficiency. 100% of the cooling energy is not reaching the rack. So you are spending money on your crack to lower the air temperature to 20 degrees, but the air by the time it reaches the rack is 22. So somewhere that air has heated up. That means you are losing efficiency. The rack front to rear, which is the most commonly thought of delta T, which is the air temperature, which is usually a rising temperature across the rack. So a small delta T can also be an indication that you're overcooling. So for example, if you have 20-degree air coming into the rack and you've got 20-degree air coming out of the rack, the delta T is 0. Obviously, that means that you are cooling nothing. There's no temperature increase across the rack. So why are you even bothering to send cold air to that rack? Conversely, a very large delta T could also be an indication of a problem. So if the inlet is 20 and the outlet is 35, but on the neighboring rack it's 20 and 25 out, then, you know, is it that those servers are doing more work? Maybe you need to balance your servers better. The other rack is under capacity, or possibly it could be an indication of a hotspot within the rack. This is why it's important to monitor the delta T at the front and the rear, because you know, a lot of people, they put one temperature sensor in the cold aisle or one temperature sensor on the front of the rack. So this means they've got monitoring of the air temperature coming in, and they say, okay, my air temperature coming into my rack is 20 degrees. Everything's good. My cooling system's working great. A server overheats and they wonder why. Well, possibly the fans on that server have broken and they're not sucking the air through anymore. Possibly some structured cabling was causing an obstruction. Possibly some blanking panels were left out and you've got recirculating hot air on one of the servers. So by monitoring only the temperature on the inlet, you are missing out on the big picture of things, which is why we recommend putting also sensors on the rear. So that way, then you can monitor your delta. And I've got 40 coming out, I've obviously got a problem. My cooling is not working, right? So something is going wrong inside of that rack. If I've got 20 coming in, I've got 25, 30 degrees coming out, then everything's okay. So monitoring the delta T not only helps you identify hotspots, but it can also help you identify how efficient your cooling system is, which I will illustrate shortly. So the next delta T to look at is the rack rear to the crack inlet. So basically what you can imagine is at every different transition of the air, we are going to monitor the difference between the temperature at the start and the end. So what we're effectively doing here is following the air around the data center. So we went from the crack to the rack, we went from the rack to the rear of the rack, and now we're going to go from the rear of the rack back to the inlet of the crack. So the hot air exiting the rack should reach the crack inlet at close to the same temperature. So if I have 35-degree air coming out of my rack and I have 35-degree air going into my crack, that means everything is working 100% efficiently. That air has not lost any of its heat. Now, how would it lose its heat? If it's 35 coming out and it's 30 when it reaches the rack, does that mean that so when it reaches the crack inlet, does that mean that I have cold air leaking from my cold aisle to the hot aisle? Because somehow that air coming out of my rack has been cooled down before it reached the crack. If that's the case, then possibly I have something going on. And the last delta T to look at is the crack inlet to the crack outlet. So in a perfect system, the air entering the crack and exiting the crack will have the same delta T as the front to rear. This would mean that 100% of the cooling energy is being used. In a typical real world, however, the crack delta T will be higher, meaning that you've got an overcapacity, which is usually to make up for inefficiencies and losses. And to explain this more clearly, I'm going to show you an example of the calculation of a perfect system. So in a perfect system, the air temperature exiting the crack would be, in our example, 20 degrees. The air entering the rack would be 20 degrees. The air exiting the rack would be 35, and the air entering the crack would be 35. That means that our delta T across the rack is zero. From the crack to the rack is zero, because it's 20 degrees coming out of the cooling system and it's 20 degrees entering the rack. So the crack to rack delta T is zero. That means 100% of our cooling energy that is being sent out by the crack is reaching the rack. The delta T across the rack of 35 to 20. So we always expect an increase of temperature across the rack. That shows that our cooling is doing something. It is entering the rack and it is carrying away 15 degrees of energy, which is energy work done by the servers. Remember, the heat inside of the servers is a direct byproduct of the amount of work they are doing. The harder the servers work, the more heat they will generate, the bigger the delta T you are going to see, up to a point whereby you are providing insufficient cooling for the capacity of that rack. Then we have the rack to the crack. It's 35 exiting the rack. It's 35 entering the crack. So again, that is a 0 degree delta T. And then across the crack, we have 35 to 20, which is a drop of 15. So you can see here, the drop of 15 across the crack is directly corresponding to the increase of temperature across the rack. So this is a 100% efficient cooling system, a perfect example. 100% of the cooling energy coming out of our crack is being consumed by the servers and carried back to the crack and cooled down and recirculating again. So this is an ideal system, and this is what you want to aim for. If you can achieve this, then 100% of your cooling energy is being used by the servers. If your numbers do not match this, then your system is not perfect and it is not as efficient as it could be. So here is an example of an inefficient system. So in this example, we have the air exiting the crack at 20 degrees. We have the air entering the rack at 22 degrees. We have the air exiting the rack at 35. And then we have the air entering the crack at 30. This means our delta T from the crack to the rack is no longer 0. It is now 2 degrees. So I have lost 2 degrees of cooling. Where have I lost it? We don't know. But somewhere between leaving the crack and reaching the rack, I've lost 2 degrees of cooling energy. Across the rack, 35 exit, 22 coming in. You can see now, this is the same exit temperature as we had in the previous example, but the air coming in is 2 degrees higher, which means our delta T is now 13 instead of 15. And then we have a decrease in temperature from the crack, so from the rack to the crack. That's 35 and it's 30 when it reaches, which means that we have lost another 5 degrees there. So now the air entering our crack is 30 degrees and the air coming out is 20, which means we now have a 10 degrees. So you can see now we have a difference between the delta T across the rack and the delta T across the crack. So this is not an efficient system anymore. We have 13 degrees of cooling. We have 10 degrees of cooling across the crack, but we have a 13-degree increase in temperature across the rack, which means that 100% of the cooling energy is not reaching that rack. If we could improve this system, then it would mean that we could lower the energy consumption because we wouldn't need as much cooling. Obviously, the servers are still operating at a reasonable temperature because the exit temperature is 35 degrees. So our servers are not overheating, but maybe those servers could do more work if I could get 20-degree air to them instead of 22-degree air. And if they only need 22 degrees, then that means I could change the set point of my crack, right? So my servers are quite happy with the 22 degrees coming in. So why don't I set my crack to 22 degrees? Because in this system, it is not perfect. If I set my crack to 22 degrees, what temperature will the air be at the rack? It will not be 22 because we are losing 2 degrees of cooling energy. So it's going to be 24. Now my servers are going to overheat. So effectively, what I'm having to do here is overcool to make up for those inefficiencies. If I could get the air leaving the crack and entering the rack to be exactly the same with no delta T between them, 100% of my cooling energy is going into my servers. So simply increasing the set point of my crack in this case is not going to help me save money because I'm going to end up overheating my servers. Everyone follow that? Okay, so next we have the delta P. This is a pressure differential, a difference between 2 points of air pressure we are talking about here. So there are schools of thought that say that perfect containment is not necessary. So a lot of you will know about containment systems in a data center, that you should segregate the hot and the cold air and it shouldn't mix. And a lot of people go to a lot of lengths and expense and efforts closing up every little gap that they can to try and make sure that hot air isn't leaking into the cold aisle and cold air isn't leaking into the hot aisle. The fact is, you don't have to have a perfectly contained system if your air pressures are correct. Now, everything always flows from areas of high pressure to low pressure. Yeah. If you blow up a balloon, you're increasing the pressure inside of that balloon. When you pop that balloon, the air escapes because it wants to balance the pressure. It wants to go from an area of high pressure to an area of low pressure. Therefore, it is physically impossible for the hot air to enter the cold aisle if the cold aisle is at a higher pressure than the hot aisle. First of all, you've got the laws of thermodynamics where the two densities of liquids or airs do not want to actually mix. And secondly, you've got the basic physical principle that the hot air is not going to flow into the cold aisle if the cold aisle is at a higher pressure, because the cold air will be pushing into the hot aisle, which is a separate issue. You don't want to be losing cold air into the hot aisle. You want that cold air to be going into the servers. The point is that the air will not actually mix, as in hot air coming into the cold aisle. So if you make sure the pressures are correct and balanced properly, then small leakages or small gaps in your containment shouldn't be an issue. So you don't want the pressure in your cold dial to be too high because it will find its way through those gaps. But you also don't want it to be too low because you don't want hot air coming back into the cold dial. But the only way that you can actually make sure this is working is through monitoring. You cannot fix or measure if you're not monitoring it. So you need the sensors in place in order to tell you what these pressures are, the same as you need the sensors in place in order to tell you what the temperatures are. So if you overpressurize the cold dial, which is basically your crack is pumping out full capacity all the time, regardless of what the servers are doing, then you're going to be forcing cold air through the racks. That is unnecessary. Those servers don't need that cold air. Conversely, if your air supply is too low, the servers are going to be sucking and they're not going to be getting the cold air that they need. So under pressurization of the cold dial is a problem, and over pressurization of the cold dial is also a problem. So you can use the Akcp sensors to monitor the temperatures, the pressure, and the power. You can thermal map individual racks. We have thermal mapping with 3 temperatures at the front, 3 temperatures at the rear, pressure differential at the front, pressure differential at the rear. And we can calculate these delta T's and delta P's around the different locations in your data center. We have non-invasive power monitoring as well. So this allows you to also check your PUE numbers. So as you make changes to the data center, you can see how it affects everything. What we have to remember here is that a data center is a dynamic, living, breathing machine. And you should be aiming to constantly tune the data center for optimal efficiency. Now, when the data center is designed, it will often go through a Cfd analysis. That Cfd analysis is based on a lot of assumptions. It's a model. It's not real life because the data center hasn't been built yet. And that CFD model will give you an indication as to how efficiently the data center may run. But it is based on a lot of assumptions, those assumptions being the amount of power that the servers are using, the crack capacity, perfectly contained system, and so on. So when you generate the CFD model, you're basing it on the manufacturer's specifications. So you're going to say this crack has a certain number of BTUs. This rack has got 42 servers in it. It's running at a maximum capacity of 8 kilowatts. The fact of the matter is that rack is not going to be running at 8 kilowatts all of the time. And that crack is not going to be outputting its total BTUs all of the time. And over time, these machines will become less efficient. Filters on the crack units get dirty, the amount of BTUs it can output become less, and so on and so on. So the data center is constantly evolving, hour by hour, minute by minute. The amount of work that the servers are doing is changing. So you must balance the air supply to match the servers. If the servers are sucking 3 cubic meters of air per second, and your air supply is only 2 cubic meters of air per second, you're not cooling enough. Your servers are going to overheat. They're going to be running their fans at a higher speed. The servers are going to consume more energy. They're going to be able to do less work. They're going to last less time. If your servers are sucking 3 cubic meters per second of air and you are supplying 3 cubic meters per second of air, then they're happy. The fans don't need to work so hard. Everything is running more efficiently, and your cold dial is going to be at the correct pressure. If your servers are only sucking 2 cubic meters of air per second, but you're pumping in 3, you're going to end up with an overpressurization, and you're going to be forcing unnecessary wasted cold air through the servers that they do not need. So by using our sensor system, you will be able to identify what your PUE is, what the differential pressures are, and what those 4 important delta T's are, and begin trying to balance them. This requires a change of mindset. A lot of data center administrators and workers at the moment, they just consider sensors as an insurance policy. And let's face it, nobody wants to pay insurance. Everyone wants to pay insurance when it's already too late. After you've crashed your car, or your house is burnt down, that's when you think, I really should have had insurance. But nobody wants to pay for it up front. And that's kind of the same issue with the sensors. No one wants to pay for these sensors because it's just an insurance policy in case my server overheats. So do I need a sensor on every rack? Maybe I can put it every other rack. Maybe I don't need it on every rack or every other rack. Maybe I just need one in my cold aisle and that's enough because it's cheaper, right? One sensor in my cold aisle instead of one sensor per rack. The point is that the sensors are not an insurance policy. They are not only there to make sure that your server doesn't overheat. They're not there just to alert you when there's a problem. They are a tool that can be used to balance your pressures, to balance your delta T's, and to make sure that your data center is running efficiently. And an efficiently running data center means it's got a lower carbon footprint, it's consuming less energy, it's costing you less to run, it's consuming less water. Ultimately, it may also mean that you can increase your server capacity without having to increase your cooling capacity. So you have a new client in a co-location data center, but you can't onboard that new client because you have no more cooling capacity. You've got to buy more cracks. If you can run your data center more efficiently, you can take on that client with the same crack units that you already have, because you can utilize the cooling efficiently and make sure that it's reaching where it's needed at the right time. But you cannot do this just by guesswork. You cannot do it through a CFD model, because a CFD model is just assumptions. You need the sensors in order to be able to actually fine-tune your system. So with the Akcp setup, you will have 20 sensors per rack. That sounds like a huge amount, right? So let's run through them. We've got 3 temperature sensors at the front, 3 temperature sensors at the rear, top, middle, and bottom. That's 6 sensors. We then have the delta T, front to rear, top, middle, and bottom. That's another 3. So you're up to 9 sensors. We then have differential pressure, top, middle, and bottom. So that is 12 sensors. We then have the pressures at the front and pressures at the rear, which is another 6, which are up to 18 sensors. And then we have voltage and current, which is 20 sensors per rack. Now, you go to most data center administrators and say that you want a budget to put 20 sensors per rack. They're probably going to laugh at you. You're never going to get approved that budget, right? Which is why we are proposing a low-cost lease model for a 1-month data center audit. You get 20 sensors per rack. It's completely wireless. It doesn't touch their network. It's the ultimate in security. There's no need to hook it up to their network at all. We ship you the sensors based on your floor plan. You just provide us a floor plan of your data center, the number of racks and the names. We ship you the sensors. They're already labeled. You install the sensors on the rack, connect them to our gateway. The gateway automatically starts sending us the data. It doesn't touch your network. You can log in, and for 1 month, you can see all of these values in the data center. So 20 sensors per rack, plus we will monitor the crack. We will monitor the airflow of the crack. And this potentially in 100 rack data center, you could be talking then about 20,000 data points. If we include all of the other ancillary monitoring that we're also going to include with the crack units and the air handlers. So with this amount of data, we can then create a CFD model that is constrained not by assumptions, not based on the manufacturer's specifications, but based on real world sensor data. So rather than the input to that CFD model being this crack has a certain number of BTUs, this rack is consuming a certain number of kilowatts, and we're assuming that it's at this temperature, we are constraining that CFD model based on real, actual, live sensor data. That sensor data will allow you to then be able to analyze hotspots and cold spots. So hotspots are a problem because you're undercooling and it potentially means that your server is going to overheat. Cold spots are a problem because you're wasting energy. You're cooling areas of the data center that don't even need it. Maybe this crack could be relocated. You could move it over here or over there, so it's closer to the hot spot, and this cold spot doesn't need so much cooling. Maybe your pressures are wrong. Maybe your containment isn't correct. But you can begin to then analyze what these issues are based on the sensor data. So the sensors don't become just a method for alerting when there's an emergency situation. They become an actual tool that you can use to analyze the operation of the data center, improve the efficiencies, ultimately lowering your carbon footprint. So this is a 1-month audit with CFD modeling, constrained by the sensor data, thousands of sensor data points at a very low cost. You can check that your data center is behaving as it was designed. You can identify overcooled areas, identify air leaks, incorrect pressures, live PUE calculations, but it requires this change of mindset. You can also use this system for data center tier testing. So what I mean by that is, through the Akcp Pro Server, CFD Analysis tools, constrained by the sensor data, you can simulate failures. So if you are a tier 4 certified data center from Uptime Institute, then you will have had to have gone through a certification process which proves 2+N redundancy tests and so on. A lot of these tests are run, and obviously you pass them and you get your certification, but that could have been 10 years ago. Since then, you've added capacity. You've moved the crack somewhere else. You've added some servers. Someone's left the blanking panel out of this place. Your air filters are dirty. The cracks are running less efficiently. Are you still able to actually meet the Uptime Institute Tier 4 certification redundancy tests 10 years after you passed them? Using our system, you will be able to simulate these failures. You can simulate what will happen if I turn off this crack. So in our software, you will be able to turn off a crack, and we will ignore the values from that sensor. And we'll be able to then simulate what would happen to your other crack units, whether they will pick up the load, or whether your servers are going to overheat, whether your delta T's are going to remain the same. This is based on the CFD model. So before you do any addition of capacity, you could run the simulated test and be able to see the results before you actually do it. This means that you can conduct the tests to ensure that there is no downtime going to be caused by the results of the additional capacity or the failure of one of your crack units. So that will allow you to do data center tier testing as well as part of this tool. So the Akcp data center audit monitoring system not only allows you to make sure your data center is running efficiently, lower your carbon footprint, lower your energy usage, lower your water usage, lower your overhead, but also as well allow you to possibly increase capacity of the racks and simulate failures before they actually happen. So that, in summary, is the Akcp system and my presentation for you today as to how the data centers are impacting climate change and what potentially you can do about it to improve the data center bottom line and help the environment at the same time. Thank you very much.
Thank you very much, Nicholas. So much insight we get from your presentation, yeah, because I think normally people only monitoring just the temperature, yeah, but basically not only monitoring the temperature, but also possible to monitor many things, yeah, including the CFD, yeah. Sometimes the people don't really notice about this. Okay, Nicholas, are you able to stand by first for waiting for the Q&A session?
Yep.
Okay, good. Okay, let's hear next. Yeah, okay. Let's hear from Yono. Pak Yono.
Ya, gimana?
Ya, Pak Yono silakan boleh sharing ke kita implementasi dari Akcp. Tadi sudah sebagian dijelaskan teorinya nih ya oleh Nicholas ya. Nah, Pak Yono nih praktisinya. Jadi kita ingin dengar juga nih ceritanya. Silakan Pak.
Oke, Nicholas, sorry ya, I speak in bahasa ya. Halo.
Yep.
Okay, I starting now. Ya.
Ya, silakan.
Oke, saya share dulu ya PowerPoint-nya ya.
Ya.
Oke, kelihatan nggak nih?
Belum full screen nih.
Udah full screen belum nih?
Masih blank di saya? Oke ya, sudah. Silakan.
Sudah, oke. Jadi poinnya hari ini kita akan bahas 6 poin ya. Jadi ada 6 poin. Apa sih pengalaman saya gitu implementasi Akcp di data center. Jadi experience kita itu ada 12 tahun. Siapa aja sih yang pakai Akcp di Indonesia gitu ya dengan solution untuk data center? Oke. Next berikutnya. Klik. Oke. Inilah customer kita. Jadi kita customer bagi beberapa section, beberapa sektoral. Ada data center hosting. Jadi seperti Indosat, GSM operator gitu ya. Indosat sebagai GSM operator, ISP seperti Indonet dan CDC. Even Equinix di Indonesia juga ada pakai kita ya. Nah, kalau di government kita dengan Indonesia Air Force, Aerospace Indonesia sama ini ya, Perlindo itu pelabuhan lah ya. Pelabuhan Perlindo 1, Perlindo 2. Jadi Sumatera dan Jawa itu udah integration. Airport Bali udah pakai solutionnya Akcp juga. TVRI juga pakai, Biro Pusat Statistik pakai. Nah, kalau di financial, Bloomberg, PricewaterhouseCoopers, beberapa bank, MNC Bank. Untuk bank kita terbanyak kita bisa sampai 700 sensor, 700 sensor for one solution ya for Akcp. Ya, kemudian di mining, ini salah satu customer kita Coca-Cola Indonesia atau di manufacturing ya. Ya ini yang beberapa customer kita lah. Sebenarnya masih banyak lagi sih customer kita gitu ya. Nah, ini 12 tahun lah pengalaman kita. Jadi buat saya solution Akcp itu akan membuat saya confident lah untuk providing sebagai data center expertise ya. Oke. Nah, apa yang si Akcp tadi kan diceritakan ya, Akcp bisa. Jadi saya juga mau menjawab tadi ada pertanyaan ya dari Pak Brian soal bisa nggak si Akcp itu diintegrasi dengan monitoring humidity jadi satu ya. Nah, ini kira-kira yang kita bisa lakukan 10 macam itu kita bisa melakukan integrasi. Satu, Akcp itu punya kelebihan punya 100 macam sensor. Jadi kalau saya cerita 100 macam sensor sampai besok nggak selesai. Oke. Kita bisa dianggap sebagai environmental monitoring, kita bisa dianggap security. Nah, kita bisa integrasi dengan CCTV, kita bisa tahu baterai monitoring. Tadi yang Pak Nicholas cerita adalah kita juga bisa tahu thermal map, ya kita bisa lihat UPS, dan kita bisa connect ke genset. Nah, kira-kira bentuk tampilannya adalah seperti ini. Jadi kita bisa tampilkan ini berdasarkan masing-masing orang punya hak, dikasih haknya seperti apa, tampilannya seperti apa, tapi overall kita bisa tampilannya seperti gini. Nah, bentuk tampilan kita pun juga ada history log dan ada bentuknya juga seperti dashboard ya. Jadi kita bisa generate. Di sini ada bentuk thermal map-nya. Nanti mungkin kita akan kasih lihat videonya juga thermal map-nya seperti apa gitu ya. Kita akan kasih lihat dan ini bentuk salah satu bentuknya bisa koneksi ke CCTV. Jadi kita bisa 10 macam ini kita gabungkan jadi satu. Enggak cuman hanya humidity doang atau temperatur aja. Oke, sampai sini oke ya. Pak Fanky?
Ya, lanjut.
Oke. Nah, balik. Coba. Balik ke depan. Oke. Nah, di sini kita membagi jadi kita membagi tadi kalau setelah kita ada cerita 12 pengalaman kita 12 tahun implementasi si Akcp, kemudian kita udah kasih lihat 10 macam fungsi Akcp yang kita bisa integrasi jadi single console. Nah, ada 3 hal penting untuk implementasi Akcp. Oke. Satu, yang namanya sensor kan butuh ada history log. Jadi history lognya itu kita bisa record semua, bahkan kita bisa menggunakan MySQL ya. Jadi datanya bisa dipakai lagi untuk di generate umpama connect ke SAP atau connect ke ERP system, karena kita pernah melakukan, kenapa si Akcp ini dibutuhkan connect ke SAP atau ke ERP system. Kemudian kita juga bisa bikin single console monitoring. Jadi contohnya gini, kalau ada umpama AC presisi, ada UPS, kita bisa tampilin dalam bentuk satu, jadi nggak multi view, multi screen, kita lihatnya juga pusing, tapi kita berdasarkan user centric gitu, ya. Nah, selain kita bisa punya history, kemudian kita bisa gabungkan jadi single console. Maksudnya single console ini anytime anywhere itu adalah kita bisa multi location yang bisa diakses dari manapun. Even dari Android lewat web browser pun kita bisa. Oke. Ya, kemudian kita bisa melakukan yang namanya recovery dan action. Yaitu contohnya gini, kita punya beberapa solution. Kalau Bapak umpama bangun data center itu ada containment, kita bisa bikin namanya smart race floor, di mana kita punya equipment smart race floor seperti ini. Jadi contohnya kalau umpama salah satu dari rack itu tiba-tiba dimasukin server baru, suhunya naik, kan bisa aja tuh servernya hang ya. Nah, daripada servernya hang, oke lah, kita pasangkan satu alat sensor Akcp, di mana Akcp sensor ini akan mengidentifikasi di rack itu suhunya berapa. Nah, setelah tahu suhunya berapa, kemudian wah ini udah kepanasan. Kalau sedikit lagi nih bisa hang nih yang namanya servernya. Nah, kita bisa nyalakan yang namanya di race floor itu ada fan yang otomatis yang gimana dia bisa push supaya dingin dari AC presisi yang di bawahnya itu ke atas dedicated, dan kemudian jadi dedicated, jadi akan suhunya menurun pada saat dia balik stabil, ini akan mati sendiri. Itu yang kita sebut kita bisa melakukan recovery dan action. Jadi pada dasarnya implementasi 3 faktor ini yang paling penting adalah kita lebih banyak mendengarkan kebutuhan customer apa. Jadi kita nggak bicara mengenai, oh kita punya produk banyak nih, sensornya. No. Tapi kita dengar dulu, kebutuhannya seperti apa, ada masalahnya seperti apa, kemudian kita site survey, dan kemudian kita akan kasih solutionnya. Makanya kenapa kita bisa bicara, kita bisa single console monitoring, anytime, anywhere, kita bisa melakukan recovery dan action, karena kita mengerti kebutuhan masing-masing customer itu berbeda. Priority pertamanya apa, priority keduanya apa, itu kita akan bicara. Pada saat kita melakukan, setelah selesai presentation, mungkin kebiasaan kita adalah kita demo unit, habis demo unit kita akan gather, karena customer akan dapat idea sebenarnya kebutuhannya seperti apa. Karena kebutuhannya seperti apa, jadi mereka tahu, oh prioritinya apa. Kemudian kita bikin timeline. Timeline itu akan kita bicara. Di fase pertama kita akan implementasi seperti ini, di fase 2 akan seperti ini, fase ketiga seperti ini. Kalau memang ada prioritas seperti itu ya. Oke. Oke ya, lanjut. Nggak cepat kan ya, Pak Fanky?
Ya, Pak.
Oke. Pada dasarnya, kalau kita bicara, memang hampir 70% tuh data center itu fokusnya seperti tadi Pak Nicholas bicara adalah cooling dan power. Kenapa? Karena semua server itu mengeluarkan panas. Dengan adanya AC presisi atau cooling, dia akan membuat kondisinya akan stable, dan power itu pun juga harus di-manage. Nah, itu akan hubungannya nanti ke arah bagaimana nanti kan dibicarakan ke arah climate atau segala macam. Jadi function dari si Akcp ini adalah pertama, kita mengidentify. Setelah kita mengidentify, kita akan tahu indikasinya, karena ada history log-nya, kita akan tahu seperti apa berdasarkan data itu, dan kita bisa menganalisanya, bahkan kita bisa melakukan recovery atau bisa melakukan yang namanya action. Nah, salah satu bentuknya, kalau di data center itu ada power distribution unit, kita bisa extend power distribution unit itu dengan memakai satu alat di Akcp, di mana kita bisa nanti tahu voltage, ampere sama kilowatt, dan datanya ini kita bisa akan lihat seperti ini. Nah, kemudian juga kalau kita bicara namanya data center kan pasti ada UPS ya. Fungsi UPS itu kan juga ini ya, kalau umpama sampai listriknya down gitu ya, gimana UPS yang berjalan. Nah, UPS itu kita bisa tahu baterai mana, karena kan isinya UPS nggak cuma satu baterai ya, jadi banyak kalau teman data center. Sebenarnya baterai mana yang rusak? Baterai nomor 5, nomor 6, nomor 7 dari 10 baterai umpamanya. Berarti kan 3 down. Nah, karena 3 down ini berarti waktu backup yang tadinya 15 menit itu menjadi namanya kurang jadi 70%. Jadi contohnya di 10 menit. Nah, jadi kita bisa dapat bentuk history log-nya bahwa baterai nomor 5, 6 ini sama nomor 7 ini down. Backup UPS kita cuma bisa 7 menit dan kita bisa propose itu ke purchasing. Kenapa? Mr. Purchasing tolong beli baterai yang baru karena baterainya sudah lama, sudah rusak. Kondisi kita cuman sekarang kita declare cuma bisa 7 menit. Lewat 7 menit, maaf kalau nanti genset nggak naik, saya nggak bisa apa-apa. Berarti satu data center itu akan down. Nah, kita pun bisa integration ke automatic transfer switch karena kita kerjasama juga ya dengan Yellow UPS, di mana kita bisa melakukan transfer switch di mana dari dari UPS. Jadi kalau listrik mati, PLN mati, UPS itu jalan. Habis UPS itu jalan kan dia backup ya. Kemudian dia harus ditransfer ke genset, generator. Nah, di genset itu kita melewati satu alat yang namanya automatic transfer switch. Ini salah satunya. Jadi kita punya untuk teknologi di power, kita punya kemampuan seperti ini. Jadi kita punya sensor untuk baterai monitoring, kita punya automatic transfer switch, kita punya DC sama AC sensor untuk mengetahui berapa sih kapasitasnya. Bahkan kita bisa upgrade yang namanya basic power, PDU basic itu menjadi kita tahu pemakaian kilowattnya. Nah, ini akan jadi menarik untuk mengetahui berapa sih operasional satu data center sebenarnya gitu. Ya. Oke, lanjut. Nah, ini salah satu faktor yang paling penting. Nah, ini contoh bentuk smart reservoir yang tadi saya sempat cerita. Ini ada containment di mana ada alat seperti ini yang dipasangkan di posisi ini. Ya, kemudian kita bisa melakukan kalau suhunya naik, kita bisa melakukan recovery karena kita punya alat thermal recovery untuk melakukan ini untuk di sini. Nah, ini contohnya ya, mungkin videonya kita bisa lihat.
Thermal maps can be placed at the front and rear of your cabinet to monitor the air in and out temperatures. In an ideal setup, the temperature coming in and out is stable and within allowed parameters. Thermal maps will detect high inlet or exhaust gas temperatures, allowing you to adjust your cooling accordingly. Thermal maps are easy to install on most cabinets using the maps and hardware provided. Thermal maps are compatible with SPC Plus and SPS Plus devices.
Nah, jadi mungkin yang saya highlight di sini, nanti tampilannya kita bisa real time. Nah, kita bisa tampilin tampilannya suhunya real time seperti ini ya. Jadi kita bisa real time seperti itu, tampil akan lihat kelihatan seperti itu. Lanjut. Oke. Nah, ini salah satu bentuk kita melakukan integrasi ke AC presisi, di mana kita integration salah satunya dengan Libet ataupun non-Invasive, di mana kita bisa melakukan integrasi ke UPS juga, ke AC presisi juga. Kalau AC presisi bentuk integrasi seperti ini, jadi kita akan dapatkan hasilnya. Sebenarnya AC presisi ini menguatkan suhunya di posisi berapa, kemudian di setiap rak itu berapa, kita punya kemampuan seperti itu, kita bisa record dalam bentuk history log. Oke. Nah, ini salah satu bentuk yang lain hubungannya si Akcp bahwa kita bisa integrasi ke power, kita bisa connect UPS baterai levelnya di posisi mana, sisa waktu UPS tinggal berapa, voltage-nya seperti mana. Ini adalah bentuk tampilannya. Jadi kita bisa melakukan. Jadi kalau umpama Bapak atau Ibu punya multiple brand UPS, multiple brand AC presisi, kita bisa integrasi menggunakan Akcp menjadi satu single console. Bahkan kita bisa integration dengan beberapa network monitoring system. Ini mestinya Pak Fanky jagonya. Salah satunya PRTG ya, sama OP Manager atau Nagios yang umumnya orang pakai. Kita udah melakukan integrasi dengan beberapa brand ini di implementasi customer kita. Nah, ini contohnya. Ini mungkin saya kasih contoh kenapa kita memilih Akcp. Nah, ini kita bagi section-sectionnya bahwa kita punya 100 lebih macam sensor. Jadi buat saya kalau untuk implement data center, pakai Akcp itu lebih enak tuh. Kenapa? Ada masalah apa, ada butuh sensor apa, ada variannya banyak banget gitu loh. Jadi enak buat saya untuk mengimplementasikan si Akcp karena banyaknya sensor yang ada 100 lebih. Nah, kalau lihat bentuknya adalah seperti ini. Salah satu bentuknya. Ya. Jadi kalau kita cerita 100 macam sensor, nggak selesai lah besok, saya jamin itu. Ya. Oke, nah ini salah satu bentuk yang lain, kita pun bisa melakukan smart rack. Ini biasa dipakai di data center hosting.
Using RFID proximity cards, you can gain access to the cabinet. In the event of a power failure, the cabinet will remain secured, but access can still be made using the mechanical key lock override. Manage access restrictions and set schedules using access per server, which comes free with any Akcp device. Access per server also monitors real time and generates reports on user activity. Access events can be synchronized with video footage for verification through access to cabinet.
Oke. Nggak bisa di-pause ya, Dek. Oke. Poinnya adalah umumnya data center hosting akan happy menggunakan solution ini, di mana mereka bisa membatasi orang siapa aja yang masuk. Pada saat dia masuk, kita bisa connect ke CCTV, kita bisa lihat siapa sih yang lagi masuk. Kita sampai bisa ke level itu, ya. Dan kita bisa atur schedule-nya. Umpama Pak Dede hanya boleh hari Selasa dan hari Rabu. Jadi pas dia datang hari Kamis, maaf dia nggak bisa masuk gitu loh. Nah, kita bisa atur sampai ke level itu untuk isu security type. Nah, ini contohnya kita bisa connect ke CCTV, kita bisa lihat siapa yang masuk. Oke. Nah, ini contohnya kita juga punya kemampuan bisa akses door. Oke. Balik lagi. Oke. Nah, apa sih salah satu yang kita ini bahwa Akcp itu nggak cuman hanya di sana gitu. Kita maju satu langkah, kita udah siap dengan menggunakan wireless untuk di data center. Kenapa wireless ini penting? Mungkin saya kasih gambaran adalah mengenai wireless itu adalah gini. Kita punya data center di satu gedung. Kita punya ruangan genset itu di gedung lain atau di luar dari data center. Nah, kan nggak lucu dari data center itu ditarik kabel fiber atau kabel UTP di mana jaraknya lebih dari 100 meter. Terus juga mesti bobok jalannya segala macam atau bobok tembok gitu. Kan implementasinya lama. Nah, dengan adanya teknologi wireless di Akcp ini, kita bisa melakukan instan gitu loh. Oke, untuk beberapa site tertentu, fine. Pasang aja yang wireless, kita bisa connect. Nah, mungkin contohnya saya bisa kasih lihat di sini. Ini kita punya beberapa sensor, jadi kita ada gateway-nya juga, kita ada sensor untuk fuel sensor. Jadi kalau kita bicara ruangan genset ada di gedung sebelah, di gedung sebelah itu kita punya yang namanya tangki. Nah, tangki itu berapa liter, kita bisa tahu ketinggian tangki itu berapa liter, persentase tangki sisanya berapa liter, dan kita akan tahu, oh, tangkinya literannya tinggal 20% lagi nih. Wah, ini mesti suruh orang nih beli bensin atau nambah bensin. Nah, dari segi sistem karena kita udah punya history log, kita pun bisa report ke manajemen selama accident kemarin, electrical down, kita bisa tahu pemakaian fuelnya berapa liter. Itu kita bisa tahu semua, dan itu kita bisa implement seperti ini. Jadi kalau nanti emang Bapak dan Ibu tertarik, kita punya demo unitnya, kita bisa pinjamkan untuk kemampuan untuk bisa melihat solution seperti ini. Oke. Oke, kalau dari saya sih itu aja sih mengenai solution Akcp ya. Kalau Pak Fanky, saya balikin ke Pak Fanky, mungkin kalau ada pertanyaan kita jawab itu.
Oke, bisa di stop dulu Pak share screen-nya, kita akan masuk ke sesi Q&A. Oke, jadi mungkin biar kenal wajahnya nih, Nicholas kan nggak bisa tampil wajahnya, jadi Pak Yono boleh kalau boleh tampil wajahnya. Bentar, saya add ya. Oke. Nah, jadi Nicholas, now our Q&A session ya.
Yeah.
Okay. Where are you? Okay.
I'm here.
Yeah, okay. So this is some question from the audience. Let me see first, yeah.
From the chat?
Yeah, from the chat. Okay, I think I will select some.
Okay.
From, I think this is from Pak Arifandi, is I think more on the, does the POE of 1.0 that 100% free cooling from outside air can be too risky, that the outside air is dirty and have uncertain condition that lead the damaging the device. I think it's valid for Indonesia, yeah? What do you think, Nicholas?
Yeah, well, you know, I mean, in Indonesia anyway, you're never going to get 100%, free cooling with outside air. In fact, your outside air is, going to be higher in temperature than just recirculating the air inside. But, I did mention that a PUE of 1.0 is really not achievable, even in a cold country, if you're doing it in Alaska, Norway, etc. Because, yeah, you're right. You have to bring that air in with fans. You've got to suck that air in somehow, which is going to consume energy. And it has to go through filters. And you have to humidify the air. So, a PUE of 1.0, 100% free cooling is never going to be achievable. The closest I think that anybody has got is a PUE of about 1.1, which factors in then, like I say, those additional power usages used for actually sucking the air in, filtering it, and humidifying it. But, I have been in data centers. I went to one, I'm based here in the Philippines, and I went to one in Manila, which, is similar kind of environment to Jakarta when it comes to air quality. And they were bringing in some outside air and not filtering it. And literally there were black marks all over the walls. So yes, you do have to consider making sure that the air is clean when you bring it in. Although in countries like Alaska, Norway, Iceland, the air is already pretty clean, but still there's always going to be some dust and stuff in there that, should be filtered out.
Yeah, that's a challenge, yeah. Okay, the next question from Pak Sugianto. I think I select the second question. What is the good indicator of the PUE? Yeah. Nicholas.
A good indicator of PUE is a low number, so the higher your PUE number, the worse it is. The lower the PUE number is, the better it is. So, it's as simple as that, really. The lower the number, 1 would be the lowest you could go, which is 100% free cooling, and if you were at 2 times, that would be 2.0. So at 2.0, it means that for every $1 you're spending on cooling, you're also spending the same on energy. And if you're at 3.0, then you're spending more money on cooling than what you're actually spending on your IT load. So the lower the number, the better your PUE is.
Oke. Mudah-mudahan clear ya Pak Sugianto ya. Berikutnya dari from Pak Brian ya, Pak Brian dari Berka ini. Akcp can help integration multi data center monitoring system for humidity. Does Akcp has own specification sensor to improve the solution? Integration multi. Okay.
Yeah.
Continue.
We have the thermal map sensor that provides temperature temperature and humidity. Those sensor data is available to our system, but also any third-party system via SNMP. So if you have multi-location data centers, then you can put our sensors in each one of those locations. And through AKC Pro Server, you've got centralized monitoring of all of your locations. So certainly we can handle a single site or multi-site data centers as well.
Ya. Oke, mudah-mudahan clear ya, Pak Brian ya.
Mungkin saya tambahkan kali, boleh?
Ya, silakan.
Jadi gini, Pak Brian, mengenai Akcp ini, kan di sini bilang multi data center monitoring system. Jadi pada dasarnya kan kita bicara data center itu ada equipment-nya, di facility ada hardware-nya. Kalau multi data center kita jawab kita bisa. Jadi umpama yang saya udah pernah implement itu kita melakukan implementasi di Sumatera, Jawa, dan di Kalimantan. 3 island, Java, Sumatera, and Borneo. Kita bisa dengan 18 location, dengan 18 lokasi itu kita bisa integrasikan jadi satu. Dan salah satunya itu kita memang salah satu dasar implementasinya itu mereka concern mengenai temperatur sama humidity. Nah, ada salah satu customer kita, mereka concern masalah humidity karena mereka perusahaan pharmaceutical. Jadi mereka nggak pengen bahan obat mereka itu humidity-nya itu sampai lembab banget. Karena kan kalau kita bicara di Indonesia, humidity-nya kan tinggi tuh, di atas 60-70. Which is menyebabkan lembab, makanya kenapa kan bisa ada rayap atau apa, karena kita kan di tropical island lah, di tropical country gitu ya. Nah dengan adanya Akcp kita juga bisa memonitoring karena kita punya sensor monitoring untuk humidity. Nah, jadi kalau umpama ada multi location yang dibicarain data centernya butuh humidity, ya kita punya sensor humidity lewat software yang tadi saya sempat kasih lihat yang kita bisa melakukan integrasi untuk 10 macam feature, itu kita bisa tampilkan multiple lokasi, umpamanya satu di Bandung, satu di Jakarta, satu di Bali, itu kita udah pernah melakukannya, Pak.
Ya.
Boleh itu menjawab nggak, Pak Fanky?
Ya, harusnya menjawab ya, karena kita pun beberapa kali juga melakukan hal yang sama. Oke. Kita lanjut berikutnya Pak Andreas Roda Sakti. Is there any possibility for Akcp to review how the cooling or monitoring humidity works in his company, Pak? I think possible ya. Nicholas, what do you think? Because you have the service, that kind of service, right?
Well, we can provide a monitoring system. Like I say, we are going to be releasing the lease model, whereby you could just get the sensors for a month, try it out, receive a report, an analysis. If you like it, you can keep it. If not, you can send it back, and you just paid for 1 month kind of rental of the system. But yeah, if you contact us with your kind of size of your data center, the requirements that you've got, then we can put together a proposal that would make everybody happy.
Ya, Pak Yono mau nambahin?
Oke, ini ada pertanyaan ya Pak ya. Pertanyaannya dari Pak Andreas ya. Satu, untuk melakukan unplug kabel power dari DC PLN tidak hanya turn on, apakah membantu penghematan energi? Jadi gini Pak, mengenai penghematan energi di data center itu, segala sesuatu yang namanya penghematan, itu pertama kita harus tahu trennya dulu. Kalau tanpa kita tahu trennya, kita tidak bisa melakukan eksekusi bahwa itu bisa melakukan penghematan. Jadi yang pertama dilakukan adalah Akcp itu bisa memonitoring. Dengan kita bisa melakukan monitoring, kita tahu jam berapa hal apa yang harus kita lakukan gitu. Contoh yang saya pernah lakukan Pak, gini. Zaman dulu server itu hanya ada single processor. Kemudian datang dengan namanya server multiple processor. Nah, kalau dulu server yang single processor itu umumnya 2U. Satu rak itu kita bisa pasang 20 server. Nah, kalau sekarang nggak usah, Pak. Kita cukup beli yang satu server, isinya mungkin 4 prosesor, jadi bentuk fisiknya mungkin cuma 5 unit server, Pak. Nah, bagaimana kita membuktikan ke manajemen kalau yang teknologi baru ini lebih murah? Nah, kita punya alatnya di Akcp yang bisa memonitoring daripada beli 20 server yang teknologinya udah lama, kenapa nggak diganti yang multi prosesor? Itu lebih murah karena biaya listriknya lebih murah, Pak, gitu. Nah, itu kita pernah melakukannya. Jadi kalau emang nanti dibutuhkan, Pak, lebih banyak ke nanti mungkin Pak Fanky lebih banyak ke arah getting information ya, Pak, ya.
Iya.
Nanti kita akan carikan solusinya. Bagaimana caranya melakukan efisiensi. Ini mungkin saya kasih satu gambaran kecil, logiknya seperti apa untuk melakukan yang namanya efisiensi. Seperti saya bilang, efisiensi itu bisa dilakukan kalau kita udah tahu trennya, Pak. Dan kita udah tahu konsep semua data-datanya lewat history log-nya itu kita tahu, baru kita bisa melakukan eksekusi. Nah, terus bagaimana yang seperti tadi saya bilang, Akcp itu bisa melakukan setelah kita bisa history log, kita bisa kita melakukan single console, yang terakhir kita bisa melakukan recovery dan melakukan action. Actionnya itu adalah bentuk yang Bapak mau, efisiensi itu ya, Pak. Jadi untuk sekarang ini saya nggak bisa ngomong karena kita mesti assessment, Pak. Tanpa assessment kita nggak tahu bagaimana caranya kita melakukan efisiensi terbaik di tempat Bapak. Mungkin menjawab nggak Pak Fanky ya?
Ya, gimana tuh Pak Andreas? Ada mau tanya lagi atau cukup? Silakan boleh dijawab atau chat. Pak Andreas masih ada? Oke, saya lanjut dulu nih ke beberapa yang lain ya. Jadi, I think this will fit to Nicholas ya, because I saw some publication in Akcp related to the climate change. How would you advise we go about educating ourselves further on climate changes? Nicholas.
Well, I'm not a climate change expert, but basically, you know, what I covered in the presentation, you know, ways that you can lower the amount of energy that your servers are using, or any way that you can lower the amount of energy that your facilities are using, whether it be a data center or an office or any other building, you know. Yeah, it's easier said than done, especially living in the tropics, right? I mean, I couldn't survive here without air conditioning. So, you know, just like a server, I need to be cooled as well. But where you can, if you can, you know, lower the amount of energy that you're consuming, then it's going to have a positive impact on the environment. As far as data centers go, you know, balancing the server load, you know, everything that I covered really in my presentation, making sure that the cold air is going where it needs to be, making sure that you're not cooling areas that don't need to be cold. You know, a lot of modern servers can run at a lot higher temperatures than people think. Yeah, it's another common thing is that, you know, people running their data centers at 18 degrees, you know, and they really don't need to be. You know, a lot of data centers can be quite happily run at 23, 24 degrees. You know, some people are cooling cabinets, which have got one server and everything else is network switches. And the network switches, you know, can run at 35 degrees. They can run a lot higher temperatures than what a server can. So is it necessary to cool those? Maybe you can relocate those somewhere else, or you could put a non-perforated front door on them because you don't need to suck in any air. You know, there's lots of little things you can do, but especially in a large data center, a lot of little things add up to a lot.
Okay, good. Thank you, Nicholas. So the next question, Pak Christian Andi Wibisono. Bagaimana, I think this to Pak Yono ya, bagaimana cara monitoring dan mengoptimalisasi airflow di ruang data center agar pendinginan ke perangkat lebih merata? Apakah kita bisa mengetahui heat map ya, hotspot dari perangkat yang ada di data center? Tadi sebagian sudah dijelaskan ya. Mungkin Pak Yono mau nambahin.
Oke, mungkin kita balik ke presentasinya dulu ya Kak. Jadi gambarnya bisa kelihatan ya.
Silakan.
Jadi gini, kita punya satu solution di data center, Terutama kalau kita bicara adalah Nah, yang pertama. Oke, kalau kita lihat gambar di sini, kita bisa tampilkan menunya adalah umpama kita punya ruang data center bentuknya seperti ini. Kita bisa pakai color coding, di mana kalau warna hijau itu adalah aman, warna kuning itu ngeri-ngeri sedap, gitu. Warna hijau oke, gitu kan ya. Nah, kita bisa juga kalau pada saat kita klik seperti ini, kita klik, ini akan tampil real time. Karena di sini kita bisa tahu suhunya di ruangan rak ini seperti apa bentuknya. Dan ini bisa ditampilkan dalam bentuk dashboard seperti ini. Kondisinya kalau hijau aman, merah itu babak belur, kalau kuning itu ngeri-ngeri sedap. Nah, ini contohnya yang kita bisa tampilkan. Pertama, kita tahu, kita punya history log-nya, di mana history log ini akan menandakan bahwa ini direkam. Jadi kita bisa tahu trennya nanti. Oke. Kemudian kita juga punya cara melakukan recovery-nya, yaitu adalah apa? Kita punya solution seperti ini, di mana di bawah rest floor, kan rest floor ini kita kan kasihnya yang bentuknya perforated. Nah, di bawah rest floor akan dipasangkan alat seperti ini yang bentuknya kipas, di mana si alatnya, sensornya, si Akcp ini adalah sensor temperatur. Dia mengetahui bahwa di rak itu mulai panas nih. Nah, kalau mulai panas adalah kita bisa membantu dengan nge-push menjalankan yang namanya fan, smart fan yang ada, yang di-trigger untuk hidup oleh si Akcp ini karena suhunya naik, dan kemudian dia akan memberikan menambah dinginnya itu ke rak dedicated. Jadi akan bentuknya seperti ini. Nah, ini cara kita membantu melakukan maksimalisasi di mana di ruang data center itu kita bisa melakukan seperti itu. Bahkan kita bisa melakukan hal yang lebih ekstrim. Contoh, kita implement di salah satu bank P. Saya nggak bisa sebutin karena kita punya non-disclosure agreement.
Ya.
Ya, jadi di bank P ini mereka mau melakukan di mana satu row di ruangan data center itu mereka mau ada satu rak yang khusus untuk master sama visa yang nggak boleh down karena itu rak itu milik orang gitu. Gimana caranya dibuat rak server ini, rak server yang 42-nya itu adalah yang terakhir mati, yang lainnya mau mati duluan terserah, yang ini yang terakhir. Nah, dengan solution seperti ini kita bisa membantu. Kenapa? Satu, kita bisa membuktikannya karena kita punya history log. Kedua, kita punya sensor ini yang mengindikator bahwa hal itu akan bermasalah. Oke, sudah bermasalah karena suhunya naik. Terus kita pun bisa melakukan recovery dengan adanya fan ini, di mana yang lainnya panas, ini kita dedicated khusus hanya untuk kasih dingin. Kurang lebih seperti itu ya. Jadi saya mau menjelaskannya lewat gambar. Bentuk-bentuknya, jadi daripada kita bicara mengenai teori ngomongan, jadi ada bentuk produknya, ada bentuk ilustrasinya akan seperti apa, cara kerjanya, unitnya seperti apa. Kurang lebih begitu ya Pak Fanky. Apakah ini menjawab Pak Fanky?
Ya, jadi mungkin mudah-mudahan menjawab ya. Pak Kris bertanya lagi nih ya, apakah kita bisa override untuk pengaturan cooling fan-nya, override, jadi dikontrol juga untuk pengaturan?
Bisa. Karena di sistemnya Akcp itu kita punya kemampuan adanya kasta. Jadi ada levelnya admin, ada levelnya orang cuma bisa lihat doang, ada levelnya orang bisa merubah sesuatu. Jadi itu kita bisa batasin. Di mana kalau level super admin kita bisa melakukan override. Ya, kita bisa melakukannya. Apakah itu menjawab Pak Franky?
Ya, gimana Pak Christian? Cukup ya? Saya langsung ke pertanyaan terakhir nih, soalnya waktu kita udah jam 3.43 nih ya. Bentar, saya lihat tadi ada pertanyaan menarik ini ya dari Pak Sebentar. Mana tadi ya Pak Muklis? Bentar. Oke. Pak Muklisin, which one is effective in cooling system using precision air AC or in-row for power efficiency? Ya, Number 2, does tool of Akcp not only monitoring but controlling too? So like building automation system, it can be automated and make efficient power and other. I think Nicholas, if you have some opinion about this question.
Which question is this one? I cannot see it in the chat.
Oh, Pak Muglisin, I think after the question is which one is effective in cooling system using precision AC or in raw cooling for power efficiency? Number 2, does tool of Akcp not only monitoring but controlling too? I think number 2 is already mentioned by Pak Yono, ya. Is not only monitoring but can controlling too. But in your opinion, what is more effective using the precision aircon or in raw? Yeah.
I think it depends on the size of your data center and what your setup is. So, you know, if you have an in-row cooler in a smaller data center, let's say, you know, you've only got 12 or so cabinets and you want to have containment, then I think the in-row cooler is more applicable, probably be more efficient. I think as well, by having an in-row cooler, if you have a lot of racks that are different, you know, say in a co-location situation where you don't know what the kind of capacity of each of the racks is, then having in-row coolers combined with a control system allows you to accurately control the temperature that's getting to individual containment aisles, and you can tune it then to the actual requirements of that containment aisle. With the large kind of precision air coolers around the perimeter, you are basically flooding the whole of the area or all of the aisles to a kind of specific temperature. And that may not be necessary. So I think it really depends on your setup. You know, if you've got thousands of racks and they're all the same, say in a Google data center, right? They've got one rack replicated 10,000 times and they're pretty much all working at the same capacity. They've got good load balancing. One larger unit or multiple larger units providing obligatory cooling to everywhere is going to be more efficient than individual in-row coolers. But yeah, if you have a situation where I've got one containment aisle, which has got a few racks in, which are running at 10 kilowatts each, and then I've got another containment aisle, and that's just full of network switches, and it's got a few servers in there, and I've only got a couple of kilowatts, it really makes no sense to be cooling that other aisle to the same temperature as the 10 kilowatt aisle, right? Yeah. So in that case, you're probably more efficient having in-row coolers in each individual containment system. So I don't think you can say one is better than the other. It's having the right tools for the job.
Agree. Okay. The last one ya, Pak Edi Wibowo. Pak Yono nih, apakah bisa digunakan untuk monitoring fire suppression system? Ya. Terus seberapa lama dan dapat diandalkan untuk sensor-sensor yang ada? Kemudian apakah ada maintenance untuk sensor-sensor tersebut?
Oke, bicara mengenai fire suspension, sebenarnya kita punya satu solution yang cukup menarik yang kita implement. Salah satunya, kita punya sensor yang namanya smoke detector. Jadi smoke detector itu akan mendetek, kalau kita bicara fire suspension di data center, itu kan umumnya di Indonesia kalau nggak FN200, kita bicaranya Novec, which is udah pakai gas. Nah, kenapa kita punya smoke detector? Dengan adanya smoke detector itu kita bisa mendetek apakah ada fire atau enggak. Nah, setelah kita tahu bahwa ini smoke detector ini mendetek ada fire, kemudian kita bisa melakukan adalah kita bisa melakukan umpama kita melakukan turn on, memberikan informasi ke umpama contoh kita ambil satu brand umpama Vesda gitu ya, kita connect ke Vesda, kita bisa perintahkan Vesda itu untuk jalan begitu smoke detector ini mendetek. Jadi yes, Akcp kita bisa melakukan akses langsung ke sistem fire suspension dengan beberapa protokol yang kita bisa. Salah satunya Modbus atau kalau enggak kita menggunakan SMMP. Jadi di Akcp itu kita punya kelebihan, kita bisa melakukan dua protokol itu. Jadi lewat konsul dari si Akcp ini kita bisa melakukan integration ke fire suspension lewat dua protokol itu, dan kita bisa perintahkan komen dengan cara melakukan cross check menggunakan smoke detector. Jadi ini best practice kita yang kita lakukan bagaimana implement si Akcp hubungannya dengan fire suspension ya. Gitu.
Ya. Oke. Yang terakhir tadi itu sensornya bisa berapa lama ya? Jadi silakan Pak Yono.
Kita bicara sensor, umumnya sensor itu bisa lama Pak, 3-5 tahun. Kita bicara seperti itu, karena umumnya kan namanya barang hardware pasti kan ada masa berlakunya ya Pak ya.
Yeah.
Jadi umumnya seperti itu, dan kita bisa melakukan namanya maintenance, karena kita bicara namanya hardware pasti kan bisa juga rusak ya Pak. Tapi pada umumnya customer saya sih kayaknya 5 tahun aman-aman aja tuh.
Iya, kayaknya lebih dari 5 tahun sih Pak Yono selama ini kita.
Iya.
Oke.
MBTF-nya tinggi Pak. MBTF-nya tinggi Pak.
Oke, Bapak Ibu rekan-rekan, mungkin itu dulu ya sesi Q&A-nya. Kita akan foto bersama dulu. Mbak Nurma, silakan.
Baik, Bapak Ibu, terima kasih atas pertanyaan yang sudah masuk. Sebelum saya membacakan siapa pemenang Oppo-nya, kita foto bersama-sama dulu ya. Mohon menyalakan kameranya.
Please turn on the camera. Silakan nyalakan kameranya, kita foto bersama dulu.
Saya hitung ya, 1, 2, 3. Sebentar.
Oke.
Ya, sudah Pak.
Oke, Nicholas, your closing remark.
Hello?
Yeah, your closing remark, please.
My what?
Closing remark.
Closing remarks.
Yeah.
Oh, okay. Okay, yeah. Yeah, well, I hope that you found what I had to say useful. You know, I'm, like I said, not an expert on climate change, but, you know, I've been working with Akcp for many years now, and, you know, I've seen a lot of data centers, both well run and badly run. And I think that, you know, there's a lot of room for improvement for most data centers, particularly when it comes to their environmental impact. Obviously, it's not something that's at the front of the mind of most data centers. You know, the primary objectives are uptime. You know, it's always maintain uptime, no matter what the cost, because the cost of downtime is usually far higher. However, there is the environmental impact that you cannot put a cost on, you know, and there will be implications. And I think that governments are going to become more involved in the regulations around data centers as it's becoming more and more prominent that they are consuming large amounts of energy. You know, it's an old saying, but whatever is innovated, the government eventually regulates. So, you know, it's already happening in some countries, even some states in the US, whereby, you know, data centers are being told you cannot get access to more energy, you cannot get access to more water. So these are important factors that must be considered. And, you know, in countries like Indonesia and Malaysia and say the Philippines, although there's not a huge number of private data centers in the Philippines, I'm not so sure about Indonesia, but, you know, they are also countries that will be severely affected by issues of climate change. You know, whether it be rising sea levels, whether it be changes in the climate, you know, these countries are less prepared to deal with those issues. And, you know, you have a wonderful nature and environment that is worth protecting. You know, I've traveled in some areas in Indonesia and in Malaysia with beautiful rainforest and so on, and it needs protecting. And so, you know, it's something that data centers, although they may not see the direct impact that they're having on the world climate change, they certainly do have an impact, and the more that we rely on data centers, which we are going to in the future, the bigger impact they're going to have.
Oke. Thank you so much. Pak Yono, silakan closing remark.
Kalau dari saya sih simple, jangan ragu pakai Akcp. Yang paling penting adalah diskusikan sebenarnya prioritasnya untuk automation di data center atau melakukan facility di data center untuk recovery atau apa. Kita punya 100 macam sensor si Akcp, jadi sebenarnya enak banget gitu kalau untuk diimplementasi banget gitu. Tapi yang kita butuhkan adalah diskusi dan sebenarnya prioritas mau yang mana gitu. Jadi discussion, cerita kebutuhannya seperti apa. Jadi kita tahu, karena kadang-kadang kita nggak kepikiran, saya cuma butuh temperatur humidity, ternyata nggak, butuh yang ini, ujung-ujungnya bikin, akhirnya project itu kita bikin fase 1, 2, 3. Kalau udah bicara fase 2, 3 project itu kita bikin namanya time frame. Tahun ini beli apa, tahun depan beli apa, yang penting kan globalnya kita bisa kerjakan gitu. Jadi mungkin dari saya lebih ke arah best practice ya, karena si Akcp ini kan orang pikirannya hanya monitoring, enggak, kita sebenarnya bisa melakukan execution dan kita bisa melakukan action gitu, recovery dan action dengan menggunakan si Akcp ini. Jadi lebih maju satu step gitu. Dengan fleksibilitas, kita juga sekarang punya sensor yang ada wireless, di mana kalau kita mau instant implementation itu bisa dimungkinkan gitu. Jadi benar-benar lebih ke arah deep conversation gitu loh, sama discussion lah. Ya.
Oke.
Itu.
Terima kasih Pak Yono. Oke, silakan Mbak Nurma sampaikan siapa aja yang dapat ininya, vouchernya nih.
Baik Bapak Ibu, sekarang saya akan mengumumkan 6 orang terpilih untuk mendapatkan voucher OPPO senilai Rp100.000. Yang pertama Pak Edi Wibowo, ada Pak? Hadir? Pak Edi?
Ya, masih ada tuh.
Yang kedua Pak Arifandi. Pak Arifandi.
Pak Arifandi nggak ada di chat nih kayaknya nih. Oh ada. Arifandi Indra Cahya ya?
Iya. Yang ketiga Pak Sugianto Sugik. Pak Sugianto, apakah ada Pak?
Ada hadir tuh katanya.
Yang keempat Pak Brian.
Pak Brian.
Pak Brian.
Pak Brian hadir? Masih ada sih chatnya, masih ada maksudnya orang.
Iya. Yang kelima Pak Muhlisin.
Pak Muslisin. Ya.
Yang terakhir Pak Sulkifli. Ada Pak Sulkifli?
Ada.
Wah, langsung nyaut Pak Zul ya.
Alhamdulillah, makasih.
Ya. Baik. Sudah?
Selamat kepada para pemenang. Nanti akan dihubungi setelah acara ini selesai.
Oke, baik. Terima kasih Pak Nurma. Terima kasih Bapak Ibu rekan-rekan sekalian kebersamaannya sore ini. Once again, Nicholas, thank you so much for sharing for us. So many things we get insight from you. Pak Yono juga, terima kasih Pak Yono.
Sama-sama Pak.
Untuk kebersamaannya bersama dengan kita sore kali ini ya. Jadi jangan lupa tetap ikuti kegiatan kita selanjutnya. Silakan monitor di eventcerdas.com. Kita ada kegiatan lagi tanggal 15 dan tanggal 16 ada banyak aktivitas. Silakan Bapak Ibu rekan-rekan bisa bergabung di berbagai kegiatan kami di webinar kita selanjutnya. Tetap sehat, tetap semangat ya. Sampai bertemu kembali di kesempatan webinar selanjutnya. Terima kasih.
Terima kasih semuanya.
Terima kasih semua. Nicholas, thank you again so much.
Thank you Nicholas.
Thank you very much.
Ya,
Bye-bye.
Pak Yono, thank you. See you again.
Bye Yono. Bye-bye.
Ya, keep healthy ya. Terima kasih semua, tetap sehat.